Greetings. Welcome to our 48th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we're going to focus on both of our March 30th and April 25th, 2023 webinars titled Geomembrane Damage During Oil and Gas Operations, Part 1 and Part 2. I presented Part 1 and Dr. Jorge Zornberg presented Part 2. I'd like to quickly reintroduce Professor Zornberg. He's a distinguished professor at the University of Texas at Austin, has over 35 years of experience in research and practice in geotechnical, geosynthetics, transportation, and geoenvironmental engineering. Dr. Zornberg conducts research on soil reinforcement, new earth retention systems, transportation geotechnics, geosynthetics, unsaturated soils, liner systems, and numerical and physical modeling of geotechnical and geoenvironmental systems. So Jorge, thanks for joining us again.
Thank you.
Okay, and Jorge gave Part 2, I gave Part 1, and we have questions from both webinars, which we'll handle in this podcast. So I'll go first. So the first 7 questions are from my live webinar, which we didn't have time to answer at the end of my webinar. So question number 1. Do you know why they use short segments of pipe, which necessitated fasteners that caused the geomembrane damage, rather than continuous lengths of pipe, such as butt fusion HDPE pipe? Jorge, do you want to weigh in on that?
Well, I can tell you that we do not know other than what was reported. It was reported that these were actually not, these were EPDM hoses, and they were chosen versus the alternative, which I do not recall exactly what was the material for the others, but these were, the reported reason is that these were more rigid and lighter than the alternative. Out of the 2 that they had, they would use the green EPDM hoses to get into the pond, and the black ones for land operations.
Right. Yeah, and they had used these hoses in many other projects, and this was just another one. Okay. Next question, number 2. Is a 40 mil LLDPE geomembrane standard for produced water? Would a thicker 60 mil HDPE geomembrane provide better protection? A lot of the geomembranes used in these processed water ponds or impaired water ponds are LLDPE, a little more flexibility. I have seen them thicker than 40 mil, as thick as 80 mil. But usually LLDPE, not HDPE, because as Professor Zornberg showed and has concerns about the subgrade, if there's a rocky subgrade, the LLDPE is more suited to conforming to it than the HDPE. Anything you want to add?
Nope, that is.
Okay. All right. Number 3, any ways to reduce the water flow rate from 2,000 gallons. Any way to reduce the water flow rate from 2,000 gallons per minute to control whipping action of the hoses? Well, yeah, just lower the pump pressure a little bit, and that'll slow the water flow rate and hopefully reduce the movement and whipping of the hoses. But I'm sure there was time constraints on the operation. So again, I think the better way to do it is put those geosynthetic sand containers on the bottom and then put the tubes on top, or the hoses on top, so the hoses aren't in contact with the geomembrane. Good? Okay, number 4. Was any effort made to quantify the release volume, estimating flow through the defects? Not that I know of. The defects, well, there was contamination off-site, as you heard in Part 1, and that led to some distressed vegetation and fines by the regulatory agency. I don't think the total release volume was ever quantified, but it's part of the remediation process to remove all that contamination. And I don't think that volume was ever calculated.
Yeah, I could add that the actual magnitude of the damages were obtained many years later. So I don't think that at the time of the events there was any inkling on the magnitude of the release. I don't think that also there was any documentation on any drop in the water level that had been reported. So I think that the answer is no. Yeah.
Right. Yeah. Okay. Number 5. Was the clay liner breach? How did the impacted fluid reach the dying tree line? Well, good listening and observation from that photograph. There was a dead tree line, and that was really what kind of triggered the regulatory agency. No breach except for the erosion or the rills that I thought developed on the side slope. Underneath on the flat base or the flat portion of the pond, there was a thin sand layer. Remember the wash screenings on the base. So really didn't see any damage to the clay liner below that. I don't know that that was ever removed, the wash screenings. Right? Were they removed?
My understanding is that really it was a subgrade, not necessarily a clay liner in the way that we designed it for water as a barrier. So it was more of a subgrade to the barrier that was the geomembrane. So I do not think that it was calculated or contemplated as being a actual barrier or a composite barrier. It was really a subgrade to the geomembrane liner.
Yeah, great point. In fact, I didn't find any hydraulic conductivity requirement of the subgrade. Yeah. Okay. Number 6, were the pond designers aware of the placement of the hoses? I don't think so, but I mean, it's kind of typical to process the water in these facilities, so maybe they should have assumed it would happen. Okay. All right, last question from the questions received during my webinar. Number 7, what is the estimated impact pressure of a hose with a 2,000 gallon per minute flow rate? Jorge, you conducted some lab tests.
Correct. So one thing that the flow rate is really was not evaluated, and when you think of the flow rate, this may become an issue if there is any disturbance and consequently a lateral movement or a whipping, as some have called it. Now the actual impact that can be measured is by the weight. And so the weight that we calculated was when the hoses were submerged were on the order of 30% of the weight that if it were filled on air. So the actual impact of the flow rate, I don't think that is something that is trivial to calculate, because it's more of a, if there is any impact, it will be more of a dynamic impact on what is the impact of a movement that will occur. So the answer is no. It was not calculated directly. It was calculated more of a gravitational effect of having the hoses sitting on the liner.
Right. Okay, now I'm going to shift to the questions submitted after my webinar, and these were submitted via the post-webinar survey form. So thank you for submitting your questions through the survey. Number 1, could a side slope riser pipe have been used with the discharge hoses inserted into the riser, have worked, or be used for future designs? Oh, that's a great idea. I think you could encapsulate the hoses in, say, a bigger, let's just say an HDPE corrugated pipe or even a smooth pipe, and let it just sit there. And then the hoses can wiggle within that and not be bouncing around on the geomembrane. Yeah, that's a nice idea.
Yeah, I think that if there is anything coming out of this discussion is that little thought has been put by the oil and gas industry into what operations in this type of liners may do. So even common sense suggestions, I think that are very welcomed. Yeah.
Yeah. Number two, why did you not use a 60 mil HDPE double texture to avoid damage, as we know that the operation will cause problems to the liner? Well, let's see, it was textured on one side, which was the side up. And I mean, interface strength wasn't that big of a deal with the subgrade, so I guess the designer didn't feel it had to be double textured. And as far as the 60 mil HDPE, we covered that in the first question, that because it was a rocky subgrade, or certainly not a prepared compacted soil liner, that having a little more flexibility in the geomembrane was probably desirable. Okay?
Yeah.
All right, number three. Was any effort made to determine the volume of water released through the defects? We answered that, and the simple answer is no. Is the site remediation complete? That's a great question. By now, maybe it is. I don't know if they completed it.
I think that it is. I think that, yeah.
Okay, so yeah, maybe by now. And just in terms of timing, this is probably 7 or 8 years after the case, right?
Yeah.
Yeah. So, and keep in mind though, they were being fined per day for the release, and now we're talking about 7 or 8 years. So, okay, number 5. Was there an operations and maintenance manual associated with this project? The answer is no. Absolutely not. And that's a good point, that maybe it should have, that shovels and other equipment should have been used on top of the geomembrane.
The documentation that is available is that this was actually originally designed as a freshwater pond. So definitely a lot more sophistication should have come in terms of the design, the operations, the maintenance. And this is a lesson learned for the oil and gas industry in general.
Yeah. Okay, number 6. Were any of the geomembrane panels lifted to see if there was some erosion of the compacted clay layer in other parts of the pond? Jorge, did you do that?
It was not done, and actually the parties, when this happened, was several years after the fact. So, but it was not reported. So the fact that it was not reported, no damages were reported, no defects were reported, and consequently the conditions of the subgrade were not reported. So it's an assumption, but possibly the best possible assumption, that there was no such conditions in other portions of the liner.
Okay. Let's see. Number 7. Has the same type of damage been found in other produced water ponds? If not, what was different in the construction or use of this pond? Great question. So since our webinars, I've received a number of email messages from around the world, not just the United States, of other type of damage, similar damage in produced water or impaired water ponds that are subjected to this water processing process. So it has happened elsewhere. Your thoughts?
Yeah, so I think that we have two aspects converging in here. One is the subgrade conditions, and the other is the operations of water treatment and operations in general. These ponds are meant to have hoses during operations, even if it is during fracking operations, you need to dispose and suck liquids. So I think that both the practices for quality control need to be adopted. They exist, but they need to be adopted in the oil and gas industry, and new procedures for operations could benefit the future projects.
Okay, number 8. The use of the buoy seemed like a good idea, just not used widely enough maybe. Would it be prudent for the diffuser to have a buoy at either end to keep it from being in contact with the membrane? Yeah, I think many more buoys, or again, these geosynthetic sand containers, because even the buoy that was used, and Jorge, jump in, I thought it was pretty small. So it would, I think the hose could easily pull that buoy around some.
The buoys, as I understand it, the buoys were only used to keep the hoses on the surface for the case of the suction hoses, which were reasonably short. Buoys were not meant to raise the discharge hoses, which were very long. So I am not convinced that buoys, or at least the size of the buoys that were used, could be the solution to avoid contact. Either the contact is going to occur and provisions need to be made for that contact not to be damaging, or something other than buoys need to be used, much more robust, if the plan is to keep them afloat.
Yeah, because the one buoy, let's just talk about the one closest to the fence. It was tied, so the buoy was tied to the hose and then tied to the fence. But there wasn't a similar tie to the other fence, right? It was just that one tie. So it could go towards the fence and then come back, go towards the fence and come back. In other words, it still could move.
Correct. Now, you could argue that if the buoy disappears, when the picture was taken, probably not during operations, but if the buoy disappears, then you know that the buoy is not enough to keep it afloat. So, but that was not even the intent for the discharge hoses. And I believe that the most significant potential impact would have been for the discharge hoses that were the long ones. The buoys that we saw in the pictures were for the suction hoses that were comparatively short.
Yeah. Okay. Number 9, do you have an example of the geosynthetic sand cushion? Is there a risk of it floating like tow ballast tubes can if there is entrapped air? Yes, there. Shoot, I do have photos of those geosynthetic sand cushions. So it's basically a geotextile tube with an opening, and you can fill the opening with sand and then just sew it closed. But they're heavy enough that they don't float. Even underwater, they will not float. Sorry, I didn't bring a photo of it, but I think if you just Google geosynthetic sand cushion, you'll see that. It's like a long sandbag.
Mm-hmm.
Okay. Did you consider conveyor belt as protection? So, would maybe putting the hoses on a conveyor belt on top of the geomembrane?
I do not understand. Just for clarification, both Doctors Stark and I had nothing to say about the actual operations. This is an after the fact evaluation on what could be done in the future and in future operations to minimize this damage or this concern. I'm not sure how to conveyor belts could what
They're thinking just, you know, the material that a conveyor belt's made out of is very strong and puncture resistant. I think they're thinking just lay the conveyor belt material on top of the geomembrane and put the hoses on top. I think that would be fine as long as the conveyor belt material was wide enough that the hoses could not leave the conveyor belt material. Sort of like a rub sheet, just a stronger rub sheet. Okay. Okay, so now I'd like to turn to Professor Zorberg's questions, and he has both questions that we didn't get to during the live webinar, and he has also some questions that were submitted in the post-webinar survey. So Jorge, take over.
Well, thank you very much, Dr. Stark. And yes, I'm gonna read the questions that we were not able to get to during the webinar. So the question number one is, what was the mean water head and when was this GMB produced? And the question continues, could a more ductile polyethylene GMB have performed better? And we answered that in part. And also, can you repeat your answer regarding the brittleness of the geomembrane? How aged was the geomembrane? And the ruptures, to me, to the person asking the question, look ductile. Many good questions in this one item. So let me go actually sub-question by sub-question. What was a mean water head? I think that it was reported that it would range from 10 to 16 feet. That was, I'm not sure at the time of the water treatment, but it has ranged from 10 to 16 feet based on the information that we have available. Could a more ductile polyethylene geomembrane have performed better? Dr. Stark already addressed partly this question. I think that ductility is good, but this was an LLDPE. So among the products that are available, this is a reasonably flexible material. Can you repeat the answer regarding the brittleness of the geomembrane? And actually, this is a very good point, and I remember being asked this question, and I think that the issue was, or I addressed it more on the shape of the defects, and by that I meant that the defects look more brittle, but maybe that was not the right term that I should have used. What by brittle, I suspect that many may think some sort of the brittleness that you could see in a stress cracking, where you see some sort of a shattered geomembrane. That was not the case. What I meant to say is that the defects were with a well-defined shape. So it was not, they were not strained, they were not roughened, they did not have a pattern of scratches. They were very well-defined shapes, and that's what I would mean by by the description that I used as a term that I used at the time that I mentioned brittle. Probably is more well-defined shape. Now, what the question continues, the ruptures to the person asking the question look ductile. And maybe this is a topic for research. What should be the right fingerprint of defects in geomembranes? And we know what they look like when we do rapid tests in the lab. What are the expected shapes when time has passed by, and how can we describe defects? And I don't think that we have a very well agreed upon way of describing them. What for me maybe with a well-defined shape, for you maybe too strained, or maybe ductile, maybe brittle. I could say I'm interested to know what the person asking the question means by the ruptures look ductile to you. I could describe them as well-defined. No straining, no pattern of scratches. They were well shaped, clearly with a clear shape that was identified in the defects. Thank you for the good question. Question number 2, what was the liner material? Was it HDPE, and at what thickness? This was answered, it was 40 mil LLDPE. Tim, do you have any follow-up question on question number 1?
On just number 1 of 2 points, I agree. I think having some damage codes, just like we have break codes for the seams, whether it's in the parent or not, could be really useful, especially in a forensic manner like you and I were involved in. We could speak the same language. Second is, now that this person is asked, could a more ductile geomembrane have performed better? This opens the door for other types of geomembrane. For example, I think a reinforced geomembrane here would have been much better. That's kind of like the conveyor belt. The conveyor belt has reinforcement in it and a hard surface on both. So you could have specified a reinforced geomembrane, maybe 45 mil thick, and that would have reduced the potential for puncture, whether it was from the top down or the bottom up, however you want to look at it.
Thank you, Tim. So question number 3, why would the defect be brittle fractures rather than ductile if it was not exposed to UV? Again, here's a terminology aspect. By brittle, I believe that we do not mean brittle in the sense of a pattern that would correspond to a stress cracking. We mean something that is well defined, and I fully agree with Tim that coming up with terminology to describe defects and their edges and the roughness and the brittleness or ductility, I'm not sure if those are good terms that apply, that would be very beneficial. Now let me jump to questions that were asked during via survey. And question number 1 is, I don't remember the grade of stone that was used below the geotextile. What was the stone size? Well, one of the points of discussion in here was that really the design and the quality control during construction could have been significantly better. There is very little reporting and characterization. All we know is from what was observed after the fact during the forensic evaluation, and they were pieces of rock certainly larger than 3 inches, but these were not, we did not collect them on site. These had been collected and all we knew is the location where they were collected. So the answer is that we do not know. They were probably larger than what they should have been. Question number 2, if a rocky subgrade was an issue, why were the holes identified in portions of the impoundment? Why were there no holes identified in portions of the impoundment where the treatment process did not occur? This is a great question. And this opens, I have a speculative answer, but it certainly upfront is speculation. So the 2 important aspects is, why did it happen where it happened in a localized portion? And there are 2 counter arguments. Well, the subgrade, if there were subgrades, and that's the point that the person asking the question is doing, why only in this corner and not in other areas of the liner? My explanation for, but the other argument is, there were locations where there were 4 hoses in this operation, and only in a portion of one of the 4 hoses is that we saw damage. We didn't see damage on equivalent, potentially even longer hoses that were in different locations. No damage were observed or reported in those other locations. So the 2 aspects of the question are very relevant. A potential explanation, and again, this is speculation, is that the way that the subgrade was reported to be was a mixture that included local soils and rocks from a blasting operation that had been used essentially because that was an excavation that was blasted on a sandstone. And the reported information is that these shards were mixed with existing soils to form the subgrade. A speculative portion is that, or a speculation it could be that because it's a mixture, this was the wrong truck bringing the wrong material in one portion of it, and that didn't happen in the rest of the liner. That could be one explanation. I believe that the counter argument could be why the hoses caused damage in this location and not in other locations. You could argue, well, there may have been a particularly damaging cam locker at this location that was not existing in other locations. So something specific happened in this region that cannot be generalized to the entire site. And it could be non-uniform subgrade conditions, or could be non-uniform conditions of cam lockers or hoses. I don't know, Tim, if you have anything to add on that. But again, it is a good question, and at this point, we can only speculate.
Yeah, it is a good question, and we just don't know if the same level of rocks were put all the way around the pond, and we assume it was, but we really don't know.
Question number 4, can we conclude based on the fact of having rocks below the geomembrane that the holes in the geomembrane layer were caused by the shear weight of the water column above only? This is a subject of discussion, and potentially I would contend that if we have the wrong rocks that are particularly angular, the pressures are not significantly high. We're talking about 10 to 16 feet of water, but 10 to 16 feet of water is a pressure that may not be significant enough to cause puncture in a lab, but we're talking about a sustained pressure. So it's a combination of time and pressure. The answer is we do not know, but I would expect that it's very detrimental to have that pressure of water directly in contact with an angular rock over months. And that may end up leading to a rupture.
Right,
Tim.
but there was a cushion geotextile between.
True.
Yeah.
True. There was a cushion geotextile. That is true. It was not a designed. It was not a very significant geotextile, but it was. But even with a geotextile, I suspect that the pressure may be. With this pressure, you could not puncture this geomembrane in a rapid loading test. But the question is, what about if you apply this strain and then you leave the strain applied for a week or 2 or a month? Could that end up having a creep type ultimate failure and damage? That's something I recommend Dr. Stark to consider evaluating that in the new research project. So there is some evidence that time has a significant impact on the rupture due to puncture. Question number 5 is, surely once pressure equalizes above and below the geomembrane, the low density of the geomembrane will make it want to float up off the bottom. That's a question. Although the presence of pipes and or sludge may be enough to prevent this. I think that what the person asking the question is envisioning is that the flow is so much that ultimately you have the geomembrane floating on another swimming pool of water. I don't think I don't envision that happening. That would mean, in principle, that the water level, the flow rate is so much that the water level will rise and eventually the entire geomembrane. I don't think that the volumes are so significant that the water level could rise and reach this level of under pressure. So think of it that if this happens, you could see the water level potentially at the ground surface, and certainly that didn't happen. So I don't envision that, but is the issue of what is the bound, what happens with the water flowing under the liner, and there's this discussion that we have with Dr. Stark, causes erosion, equalizes. What is the mechanism? That's an important question that I don't think that we have the tools to answer directly. We can have some theories and opinions, but we do not have data or analysis up to the level to conclusively answer that. And I think that this is the last one. No.
That was the last question. So everyone, thanks so much for your questions and listening to the webinars. I had a great experience giving a part 1 and part 2 of this webinar. First time we've done that. So thank you to Professor Zornberg for agreeing to participate.
Thank you, team. This was a difficult but so enlightening approach to make this presentation. Very enriching. Thank you.
Yeah, and Jorge and I are working on papers on part 1 and part 2, and we hope to have those ready and submitted for publication here shortly. And of course, we'll post those on the website once they're ready, and you can download them with the podcast and the webinar. Okay, so thank you so much, Jorge, for joining me again from Austin, Texas. And thank you, everybody, for your questions.
Thank you, everyone. Thank you, team. Bye, everyone.